Hello, it's Duncan. We're taking a break from trying to finesse our database transactions this week and instead address an issue that has bitten us a couple of times recently. That our item type sometimes has prices and sometimes doesn't. That led us to the illegal state of a repository saving prices. In Kotlin, we like to use types to make illegal states unrepresentable, so we'll introduce PricedItem and PricedStockList to prevent further errors. That refactoring in turn raises another issue about our items and their types. Pulling on that thread leads us to introduce a new package to contain our updating code, and allows me to reflect on coupling and cohesion in mixed OO functional code bases. In the last episode, we had some confusion over our item type. And the issue is that we're using this type here, item, both for items with a price and without. We'd read them from the database without a price, in which case this price here is null. And then we go to a pricing service and use that to populate the price using a result so that we can capture any errors we had. And if we didn't get a price back from the pricing service, then this price inside the result is null. Note this is a data class with values, not variables, so we don't actually update the item. What we do is we create another item, a copy, with the price inside it. Now this nullable result of a nullable price is all a bit subtle, and it led to an issue with our in-memory items that were persisting the prices. That didn't actually affect our production code, but it took a little bit of debugging, and that's the second time we thought, it would be interesting to see what would happen if we had a different type for item with price than item without. Now it turns out we never really address items on their own, they're always part of a stock list. That's here, and you can see a stock list has a last modified date and a list of items. Now I could extract a superclass of item so that we had item and priced item, both of which were items, and then a stock list to take this item, which could be either priced or unpriced. But I think that might lead to the same confusion. So I'm going to start on the outside, as it were, and I'm going to start by creating a data class in here for priced stock list. And that's going to have the same fields as our stock list. And at the moment it's going to be composed of item, not priced item, in order that we can do the refactor one layer at a time. Okay, so where would we convert a stock list to a price stock list? And the answer is where we apply the prices. Where's that? Well, that is our priced stock list loader. Here it is. I'm going to put it over here. Let's get rid of that for now. Now, price stock list loader is a class. It has a way of loading a stock list. And when you say load, it calls this loading function here and then prices up all the items inside it. In terms of our new price stock list then, this load would not be returning stock list loading result. Let's inline that. It's not a result of stock list and stock list loading error. It's a result of priced stock list. And now this is it priced by, that's this, so this would return a priced stock list. And we're just leaning on the compiler here to chase this change through. Okay, this copy here is copy on a stock list, but we now can't do that. We can't just copy a stock list, we have to create a priced stock list. So this would return not a copy of the initial stock list, but a priced stock list. And that will have the same last modified as the stock list. And the items will be the priced items. Okay, that compiles, but it must have broken something else. Let's find out by compiling. Okay, up in app then, load stock list. Now that won't be returning a result of stock list, that will be price stock list. What's next? And now a render function that is currently taking a stock list, but we now know that we've got a price stock list. Well, that's good. Let's go to that and let's fix this one up to take priced stock list. Build again. And now our stock list rendering tests are unsurprisingly broken as well. Let's have a look at this. It has a stock list. So in fact, because the interface is effectively the same, we can just call that price stock list. Any more? With the same thing here. This is now going to be a priced stock list. And that seems to build. Let's try running all the tests. And now our price stock list loader tests are failing. Let's have a look at that. And that's saying that we had this expected price stock list here. Is that the right type? Let's have a look. No, it isn't. It's stock list. Now, how were we even able to ask that question? Back in the test here, this assert equals. This is the version from JUnit that takes object and object. Had we used assert from Kotlin test, that wouldn't have happened. So let's go and fix that by deleting those. And this time we will import from Kotlin test. And now you see that doesn't compile, which is much better for us. Any more? Okay, well, we've got the same issue here. Right, so now we can go back up to the top and we can say that this expected price stock list wants to be priced stock list. Now we can't just take a stock list and map its items, but we can create a price stock list with the loaded stock lists last modified and the items, the list of those that we were feeding in before. Remove that and reformat. Run all the tests. One failure in list stock tests. I suspect that's the same issue. Let's go and have a look. This says price stock list, but this is actually a stock list. Fix that. Now that's going to break our fixture. Our fixture takes a thing that says it's a price stock list, but it's in fact a stock list. Go and fix that. And here, this stock list now needs to be stock list, not price stock list, but price stock list copy will create a price stock list. So this time we're going to go the other way around. We're going to say this is a stock list, given the price stock list last modified and the item from our price stock list. One more time with feeling. Aha, here we are in delete items test, same issue. And you can see now all the places we were using a stock list that had to have items with prices in them, but we were only able to express that in the name of this rather than the type. But now we can say this is price stock list. That compiles and passes. Good. Well, that was quite a major change. I think it's worth checking in on its own. So this is introduce priced stock list. I think it's worth reviewing those changes in place. Let's have a look at them. So in app, we have a change to the import. That's nothing particular. And here, loading stock list now returns a priced stock list. And that's a helpful change because we now know that we can rely on it having prices. Delete items tests. Well, this is one of those places you can see that we were relying on the name of the variable before, but now had the type. Fixture, same thing. List stock list, same thing. Price stock list loader. Well, that's the place where we thunk between a stock list and a price stock list. Its test will consequently change. And here we've added the price stock list. And then our rendering hasn't really had to change because it treats its input as an iterable of item and we haven't changed the item yet. Okay, let's commit that. And now clear the decks for the next bit. This time we'll do item. And we'll do the same as we did before, which is to take this and make it a priced item. Now, a priced item can't have a null price result. It can have a null price in there if the pricing service said that there was no price for this item, but we must always have tried to fetch one. So that can be like that. And I think it would be helpful to have a constructor that took an item and a price result. This can now populate itself with the parts of the item. So we say item.id, item.name, item.sell-by-date, item.quality, and then price, and then we have item.type. Now, item type is private in there, which is irritating, so let's take that. Actually, that begs two questions. One is, does our priced item need a type? I'm going to take a punt that it doesn't, so let's just get rid of that, and then we don't need it there. And I think we'll come back to that. The other question is whether price item should have separate properties for its own ID, name, sell by date, and so on, or whether it should have a property of the item and accessors to go and get them. I don't know which is better at the moment, but I'm going to err on the side of separating these out. Let's reformat that. And now we have our priced item. Now, where are we going to use this? Well, we know our priced stock list should really be composed of priced items, not items. So let's change that and that and go and fix up the consequences. Okay, so the first one is price stock list loader. Item priced by is returning an item, but should be a priced item. And that means that we can't copy. We have to say that this is our priced item, given this, which is the receiver, this item here, and the price. It's nice, it means we can get rid of that, reformat, maybe join that, build again. Okay, now in our rendering, we're mapping this item, which was an item but is now a priced item. So our stock list view model, that deconstructs each item to a map. But it looks like this item to map is the issue. Let's go down there. This should now be priced item to map. That means this needs to be priced item. And our price string, now previously we were dealing with items, not priced items, so that it could be our price was null. Now that can't be the case, it says here, so we can remove that. Well, that's made something a little bit simpler. That's good. Build again. Okay, now we're in our tests. We've got a price stock list and we're building from items with price result. These are test functions here. And it looks to me like if we take an item and adding a price to it, these should be priced items. So this should not be this copy. We should be calling our constructor, which is priced item given this and a price. See what that fixes. Now here we've got with no price. What was that doing? It was saying make an item with a price of null. Well, that's really quite interesting. I think that's a logical inconsistency in our tests. What we'll end up with here is an item with a null price, but here this is a price stock list, so we can't have an item with no price. All we can have is an item with a price result with a null inside it. Try building that. Here we have a different issue. We're taking a priced item and we need to convert it to an unpriced item. So this with no price, let's go back here. I think it is reasonable to say we have a priced item with no price, which is item, which has ID and name and sell by date and quality, but no price. And now that shows that stock list without prices can't just copy a stock list. This should be priced stock list without prices, and that should return a stock list with the last modified and the items being the items with no price, thus converting them to unpriced items. See how that does. Now here in in-memory items, we're being asked to persist a stock list. The bug we fixed last episode was that we needed to remove the prices, but now we're given a stock list, not a price stock list. There aren't any prices. So in fact, we can just set the stock list into there. Items contract doesn't save prices. Well, we don't need that anymore because there are no prices to be saved. Well, that builds. Let's see whether it runs. And gratifyingly, it does. Let's see what other tidying up we can do. This test data, it turns out that the stock list with items and without prices are not required anymore. So let's just delete those. Now going back to item, our base item class still does have a price in it, but I think we can take this away now. Let's find out by building and running. Well, that's nice. I think we'll commit that before we go on. And again, let's just have a look at the effects. Delete items test. Well, that was a place where I think we had a logical inconsistency. It's good to have found that through the type system. In memory items, well, now we don't have to remove the prices because we don't have any when we save a stock list. Item, we've added priced item. Items contract, we can now remove a test for something that can't happen. The price stock list loader, we can't just copy the item, we have to change it into a priced item. That's the change we really wanted. In the stock list, we've added price stock list. Stock list rendering now works on priced items and priced stock lists, so it doesn't have to deal with having no price result at all. And finally, our test data is simplified a bit. I think that's good. Let's commit it. Now, I promised to return to the question of item type, because it's quite interesting that we have an item type here in item, but priced item doesn't seem to need one. Let's just have a look at the references to item type. And it seems, in fact, that that's populated in the constructor here and then used in updated by. So the type is the thing that knows how to update an item. Let's remind ourselves what it looks like. It's this interface that takes an item and a time and returns an updated item. And implementations of that are these things like conjured and standard type and updated type and brie type and so on. So it seems that we're populating this when we create an item in order to use it when we update an item. Well, that's fine. When do we update items? Let's look at the corners of that. And that's a little bit complicated because item updated by is referenced in app here as a function reference to stock to tell it how to update an item. Well, I think that's needlessly complicated. We wanted our stock to be able to specify this item update so that we could test it separately from how items update. But I think actually if we were to say that the default value for this is item updated by, then we could go back to app and we could just use the default. And that way the test can specify their own version, but the top level of the app doesn't have to be bothered by that configurability. So we'll join these, delete that, join those. Does that still pass? Okay, good. If anyone knows a shortcut for getting rid of this window, make it go away without clicking here, please let me know in the comments. But let's return to item. Now we can simply ask who calls this. And the answer is it's referenced by the stock constructor that uses it when it loads the stock. So stock has called items to load. It's getting a stock list with the items. It's checking whether that is out of date. This might be better to be called loaded stock list. So it's checking whether that's out of date. And if it is calling updated on the loading stock list, which is this thing here, which uses our item update. So the only time we actually call that updated is immediately after we've loaded the item. So I wonder whether it's worth setting a field in order to read it again milliseconds later. We'll find out whether we can make a change by saying val type equals type4 and filling in the sell by date and the name. See whether that passes the tests. It does. And now can we just remove this type? So get rid of that. And if I do, then both of our constructors have the same signature, so they're both doing the same thing. We can get rid of that one. Let's try that. Okay, that failed the test, and it failed item types for toString. Let's have a look. And that's saying that the toString of our item uses the name of the type. But that's really only for debug, so I think we could get rid of that. And we'd be passing, and item would be quite a bit simpler. I think I'm going to check that in before I do anything else. So this is remove type from item. And now I'm going to have a little look at the package structure of our program. So we'll look here, and we'll see that the items are in our domain package. Well, that seems reasonable. But this updated by was stock, and where's stock? Well, that's in persistence. So it's around items and loading them. If we look at this stock class, we see it's only got one operation, this stock list. I think we might reasonably call that load and date stock list to remind us what it's actually doing. And this persistence package is getting quite busy now. It's got our items type and the implementations of it and so on. So I wonder about pulling stock out into a separate package that's around updating. So we could take this thing and move it, wrong one, F6, to package of updating. And we'll move our little function with it. So let's refactor that, add it to Git, run the tests. That's all fine, but I suspect we had a stock test as well that we should also move. So let's find that, and that would be in here, that's stock test, and it's changed. So we'll move this in the other way, which is change this to updating and then move the file that way. It's interesting that days 2 test has changed as well. Let's have a look at that. That was testing this days 2, which is part of our stock. So we need to move that as well. Go back here and say 6, and we'll take both of those things and we will move them to updating. Don't know what that's about. Let's do it and fix it up. Oh, it looks like we just missed a function that needs to be moved. So we'll put that into here and run. Now stock test is in a different package. That wasn't fixed up for some reason. Try again. Okay, and now this should be empty and deletable. Now let's return to our item, which remember is in our domain package. Here it is. Now I think item deserves its place in the domain. Both items and unpriced items are fundamentals to our system. And in fact, priced item has an item ID inside it, which couples them and keeps them at the same sort of level, I think. This updated by, though, is only called in our updating package. Now, when we started this project, the whole point of it was how we update items. But that now is only part of what we're doing with items. We're now deleting them and persisting them in different places, and no doubt we'll be adding them, or at least priced items, to a shopping cart at some point. Now, I'm generally a fan of having operations on a type as methods on that type. But the consequences of that at the moment are that this piece of data needs to know about type 4 and all of our updating calculations. So I'm going to try making this an extension and run that. And if we do, then I think we could take this, and I'm just going to cut it by hand and move it into somewhere in our updating package, and we've got stock. Well, that's the only thing that actually uses it, so it doesn't seem unreasonable that it would go in here. Does that run? Well, we'd have a few things to fix up, and things we need to fix up are the updating tests. Well, those are updating tests, so maybe they should be in updating as well. So I think we should be able to take these tests that were in the domain and say, actually, they're only about updating. So we can take that, and that, and that, and that, and that. Maybe not that one for now. And move them into updating. Make that refactor. Now these imports are local. And we can run, can we? Okay. Now we have an issue in stock event. Where's that? Well, those are tests around event sourcing. They're still very much experimental, so I think we can just import that across the package hierarchy. And that now passes. We didn't move one test. Let's just go and have a look at what that has in it. It's this items tests. And that has a bunch of tests around no item should have its quality raised above 50 by updating, and so on and so on. These are all about updating, as you can see. Interestingly, they're only using copy. So I think, in fact, these things are testing the operations and our quality at the moment. This plus that does the coercions, that's maybe a thing we should change later, but it does show these are all about updating, so we can move this into updating as well. And that leaves us with a very simple item class with no body and just data. Good. We're not quite done though, because this item type we know is also only about updating, so I think we can move that into there and run. Splendid. So let's just review that change, make sure we think it's better and that we want to check it in. We can group these, which gives a bit more idea of the structure. So starting with our production code, we changed item and we removed updated by from it, remembering that we'd removed the type in the previous commit. In persistence, we moved stock out into updating, and this stock gained our item updated by function. And because that's the only thing that was using type for, we moved item type that has type for and all the implementations of item type into updating as well. And our app seems to have changed, and that is because we moved stock, and also we renamed that operation to load an update stock list. And then our tests, well, we basically just moved tests to the same package as the code they're testing. Is the code better this way? Well, I think it is, in as much as it collects all the code around updating, which is a thing that happens only once a day, into a single package. That reduces our cognitive load when we're working in other places in the code base when we look at item. And it would potentially allow us to move the updating code into its own module. Perhaps when it gets really complicated, another team could look after that. I think given the relationship between this and the last commit, I'm going to squash them together, make this an amend commit, and make this move item updating code into updating package. And commit that. There are some interesting lessons to be learned by reflecting on this refactoring. The first is the power of using types to express constraints on our data. We'd already seen that when we introduced the tiny types of non-empty string and non-negative int. Pricing was more subtle though. Last episode we found a bug in the in-memory items where a stock list that should only have contained items without a price actually had prices. That's an illegal state, and where we can, we'd like to make those unrepresentable, in this case by introducing PricedItem and PricedStockList. Should we have written it like that in the first place? Perhaps, but the separation has a cost, and we like to only pay for code that's likely to pay for itself. Doing the simplest thing that could possibly work and then being sensitive to where it isn't working is a good strategy, providing their refactoring skills are up to fixing things, and in this case I think they were. When we introduced PricedItem, we copied all the data. Should we just written it as an item and a price? So that would have been item and one of those. In fact, we could just have used a type alias. The priced item is a pair of item and the result of price. Either the pair or a specific data class communicate the relationship better than our existing separate classes, but would have required more changes to the rendering code. We try and build this. You see we don't have things like ID, but those we can put in by adding ID is ID of item is item.id. I think that one time I would have favoured this, but these days I tend towards making data as standalone as possible. But should we find that we're often adding properties to an item that we're then having to add to priced item, it could be a sign that structure sharing would be a better solution. Our design should support the types of changes that the system is currently going through, and if the nature of those changes changes, then a refactor may be in order. Thinking about change brings us to coupling and cohesion. Coupling is where one piece of code relies on another, and too much of it is a bad thing. When bits of code, functions, classes, packages, modules, microservices are coupled, a change in one may lead to a change in the others. Cohesion is the art of making sure that coupling is appropriate by grouping things together that should change together. Looked at this way, our previous design had the database code coupled to the pricing. Our persistence returned items, and our items had prices. Removing the price from item decouples our database code from the pricing. Priced item, on the other hand, is coupled to item. It's coupled in two ways. One is this generic parameter here. A priced item has the same ID type as an item, and the other is its constructor that takes an item. This coupling is in the right sort of direction though, because in our system we can't build a priced item without previously having built an item. If we really want to separate the two, we could move this constructor out of priced item and make it a top level function somewhere. And we'd have to fudge this generic parameter. Now before this refactor, the database code was also, at least implicitly, coupled to items updating because the item had an update method. Extension functions are a really powerful way of breaking that coupling. We made item updated an extension function defined in the place that it was needed. And because updated required type for, and type for brings in item type, let's decouple our item from this item type and all the rigmarole about updating. Now, as I said, coupling applies to packages as well as just classes and functions. And that's the reason for creating this updating package. It means we can put all the things concerned with updating in one cohesive package. We'll examine the package structure we've ended up with in more detail once we finish this database work. But you may already be able to see that we have layers where the lower level code has no dependencies on the higher level. If you'd like to see an episode where I explain package layering in more detail, then please subscribe to the channel. And if you've enjoyed this, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.